Hello and welcome. My name is Matthew Keeney, and in this presentation, I'll be discussing a simple and economic approach to annealing the nanoDot dosimeter. Now, before we begin, let us briefly describe what a nanoDot is. The nanoDot by Landauer, as shown in the figure on the screen, is a luminescent dosimeter and an effective tool to independently verify the quantity and dose delivered during radiation therapy. Now, the nanodots can be placed onto a patient wherever the absorbed dose is of concern. Typically, a new nanodot is used for each clinical session. Now, it is important to note that the nanodot can be reused by clearing its stored signal or erasing its prior dose history in an annealing process known as optical bleaching. So how can we achieve this? Well, the stored signal in nanodot can be cleared by exposing the sensitive material dosimeter to a wide range of light sources. This includes fluorescent, halogen, ultraviolet, and even LEDs. Now, it is noted that there exist some fancy optical annealing devices, such as the one shown in the figure on the left, that can be purchased. However, this is completely unnecessary, as any viable light source that is found in the clinic, office, or even your very own home is adequate enough to complete this process. For our experiment, we opted to use an X-ray film light box, which can still be found in most clinics today. The nanodots are placed within the inside panel of the light box and exposed to the fluorescent lights, which are a full spectrum. So now let us discuss the results of this process. In our experiment, two different data sets were used. The first contained 20 nanodots that had never previously been bleached before, and the second set contained 20 nanodots that had previously been bleached, re-irradiated, and hence were undergoing their second time bleaching. The nanodots were exposed to the fluorescent light for a total time of 72 hours. The nanodots are read into an OSL reader to determine their photon count, which is relative to the amount of radiation dose that they have received. And these readings were done after 1 hour, 2 hours, 24 hours, and 72 hours of their exposure to the fluorescent light. Now, in order for a bleaching process to be deemed successful, the photon count must be less than 200. And from our experimental results, we see that this occurs within 24 hours. However, it is important to note that the amount of time it takes for a complete bleaching process completely depends on the amount of radiation that the nanodots had prior to their bleaching, as well as the energy of the light used for the bleaching process. Additionally, further research shows that even after a multitude of bleaching processes to the nanodots, that there is no significant change in their sensitivity, and therefore their function and response is essentially the same. This concludes my presentation, and I thank you for your